Hi, everyone. Our show today is on OFDMA Upstream Troubleshooting, Tips and Recommendations. I'm Brady Volpe, founder of NimbleThis and the Volpe firm. With me today is John Downey, CMTS Technical Leader at Cisco Systems. John, welcome back.
Yeah, glad to be back. I was muting my phone. Remember that time I think you were doing a presentation at SCTE, and I think I called you while you were presenting.
I can't imagine that you would do something like that, John. Are you muting your rooster going on
No,
outside?
no, it's out there right now. My rooster and my turkeys.
We heard them in a pre-show. You guys all missed out. So everyone, that's listening, please drop your questions in the chat show. Our show today on OFDMA is I think it's going to be pretty interesting because we've been talking to lots of people. There's been there was a show yesterday on the same topic, and I think we'll talk a little bit about that, kind of piggyback on that. There's been a 50% increase in upstream traffic thanks to COVID. It's the gift that just keeps on giving. So lots of people working at home, children learning at home, and so we're seeing this increase in upstream traffic. Thanks to that, lots of operators are now starting to take advantage of OFDMA in the upstream. Of course, we have OFDM. That's used in a downstream, so don't get the little A confuse you on the OFDM. So A is for upstream, OFDM is for downstream. A lot of folks are under the impression that we should be able to deploy OFDMA in the noisy areas of our upstream. Lots of us are stuck with a 42 megahertz return right now. Of course, we are looking at expanding the upstream. One of the new things we have found, the interesting things, is we are running into some challenges in OFDM deployments, in particular with modems locking up once we get noise into the return. That's one of the things we'll start this conversation out as to where we should maybe place the OFDMA channel, why so many operators are running into cable modems locking up, and then we'll move on from there. So I'll start with John on the topic of why are we running into noise locking up on cable modems, or cable modems locking up in the upstream with OFDMA. What's your perspective on that? Have you heard of it? Have you seen the same thing?
So let's think about upstream noise funneling. All it takes is one house with noise to funnel back, and everybody's affected, right? The only time you have individual modem MER issues would be group delay, micro reflections that are indicative of just that one modem. But for ingress, everybody's affected. Doesn't matter where it comes in, because it's still going back to the single source on the CMTS upstream port. So we all know below 15 megahertz, we used to say 20 megahertz, I'm going to say 15 megahertz. It's usually pretty noisy. To make that worse, there's power supply noise, there's impulse noise. If you hook up a spectrum analyzer, some of the impulse noise is so fast, and the spectrum analyzer is scanning so fast, you don't catch it. If you slow down the dwell time of the spectrum analyzer and put peak hold on, you'll notice a lot of impulse noise is below 15 megahertz. So there could be problems there that just create a lot of uncorrectable effect if you're going to put a carrier down there. But you could just say, well, an ounce of prevention is worth a pound of cure. Why would I even test myself or put myself in a bad situation by using that spectrum? Then you're like, well, 5 to 42 megahertz is not much spectrum to use. I have 4 ATDMA channels at 6.4 megahertz wide. I can't even go to 42 megahertz because the real filter is 40 megahertz. So I have to stop at 40. And then I'm trying to avoid CB at 27 megahertz. And then I might have out-of-band signaling. I might have set-top box signal, status monitoring. So there's a lot of stuff that has to coincide or coexist. So they're like, maybe we can just start OFDMA, Docsis 3.1 upstream on the low end because it has LDPC and frequency interleaving and it's more robust, and I have profile management. Maybe I can do OFDMA down there.
And I think that's the natural thought. I mean, at least for me, and I even think I've told people that OFDMA with LDPC should be much more immune to noise at low frequencies. So I would think that's a natural thing to do. Let's put it at 5 megahertz up to, put it in that really noisy area. And I think we're seeing a lot of operators start to do that, exactly as you said.
And to me, I want to exploit the new technology to get better speeds. I'm
Right.
still paying licensing for this too. You pay a license for the channel, the subcarriers in the channel, regardless of the modulation you're running. So if you decide to use 5 to 15 megahertz and you're relegated to QPSK, you
For
pay a
your OFDM
premium.
channel, because it could run
Yeah,
it could run at 1024
yeah.
QAM, but to your point, if
Yep.
there's a lot of noise, it may drop from 1024 QAM all the way down to QPSK, regardless of
And
what you're
because of
paying for
noise
it.
funneling, all the modems are probably going to drop to
Right.
the lowest modulation because it is what it is. The noise is there, right? It's not like the noise is only there for one modem, unless that modem's creating the noise, which we've seen that too. Some modems actually create noise with their power supply, which is kind of strange, right? I've seen that.
Yeah, there's
I've seen cases where the noise comes and goes, but it really depends on what's out in the field. And some systems used to use those switches and stuff. I haven't seen too many of those anymore. Remember those, the switch?
the power supply for the cable modems you're referring
Yeah.
to, right? The power supply itself, that little wall wart generates noise, goes into the cable modem, comes back out the F connector on the cable modem, all the way back up to your CMTS. Those modems still exist, John, because I've worked with cable operators. They know the noise exists, they know the signature, and they can't use the upstream spectrum because of those modems that are generating that noise.
And to make matters worse with that is the upstream laser is probably an analog laser, right? They're probably not doing DAA yet. So now you have laser clipping because you have overload of not just real signals, but fake signals, noise. Noise still has amplitude. And if that happens to come in high enough, it causes laser clipping.
But I
So
think the
laser clipping,
question that I've talked to many operators about is they will put OFDMA at the low frequencies we're talking about. The modems will come online, they'll be fine. The modems will be running for a while until noise ingress comes in, and then the modems themselves, they're still online. But they'll get tickets from their subscribers saying, I'm not able to get any traffic over these modems. And that's the confusing thing for them.
so here's the interesting side note is the 3.1 modems prefer the 3.1 spectrum for their traffic allocation first, downstream and upstream. So if we cross bond OFDMA with a couple single carrier QAM, it gives us a bigger aggregate pipe. It gives us a bigger pipe to get higher peak speed. But the 3.1 modem and the CMTS are going to schedule its upstream traffic on the OFDMA first. So instead of scheduling some traffic on the single carrier QAM that might be running 64 QAM and it's legit and no uncorrectable effect, it's purposely trying to schedule on the OFDMA that's lower in frequency, that has more noise and lower modulation. So here's a case where the modem says it's doing 4-channel upstream bonding, but it's trying to do all its traffic on the OFDMA and just getting a lot of uncorrectable effect. Or it could be there's so much noise and the modem is trying to go through profile management to drop to a lower modulation, which usually requires something called a DBC, dynamic bonding change. Mm-hmm. And maybe all these variables are then locking up the modem. So the modem, you can do a ping Docsis, but you can't do a regular ping because layer 3 is locked up.
And this is not the first time we've seen this. We saw this same thing occur in Docsis 3.0 days when we were doing channel bonding and now the modems were switching between different upstreams or they're doing load balancing, and same thing happened, right? Modems would lock up. We could still ping Docsis to the modem. We could communicate to the chipset on the modem. However, it's kind of like, I've referred to this, and I know other people have too, as blue screen of death on the modem, where the modem at the layer 3, sort of the operating system in the modem itself, locks up. And that's that kind of, from an operations point of view, it's really challenging because we look at the CMTS, and the CMTS says the modem's online. But from the subscriber point of view, that modem is not online. There's no traffic going over it.
And so if you're not proactive and you just look at show cable modem, all the modems are online, you're happy. So now you're relying on your customer to call in and complain.
Right.
And they can't call in on the EMTA because it doesn't work. So they have to call in on their mobile phone, which then makes your service look even less reliable because now they have to go back to the cell phone and mobile anyway.
Yeah.
Yeah, it's a pain. And if we can ping a modem, or not ping a modem, but ping Docsis. When you do ping Docsis, it's a layer 2 ping, if you will. And even if a modem is a NIT R1, a NIT R2, a NIT RC, it's going through ranging process. Once you get to ranging complete and the modem hasn't even come on yet, it's not even at a NIT D, you should be able to do a ping Docsis.
And ping
The physical
Docsis is a
layer is done.
command that you do on the CMTS. This isn't something that you can do anywhere other than the CMTS. Ping Docsis, the MAC address of the modem.
Ping Docsis, MAC address, and then it will send a station maintenance ping. Now here's the pitfall to ping versus ping Docsis. Ping is layer 3. It's going to use the mod profile of the short or long grant, which is probably 64 QAM. When you do ping Docsis, it's doing the station maintenance burst of your mod profile.
Right.
And that's probably 16 QAM.
Or maybe even QPSK.
So if someone, yes, exactly. So if someone doesn't get a ping, but ping Docsis works, I don't assume layer 3 is hung yet. I say check your MER first.
Right.
Because what if your MER is, I'm going to give you an example. What if it was 20 dB? If your upstream MER is 20 dB, 16 QAM will work fine. So the station maintenance ping will work. But the regular ping at 64 QAM is not going to work because the breakpoint for 64 QAM is around 23 dB.
Correct.
So, my troubleshooting would be ping versus ping Docsis, look at the MER, see if it makes sense. If MER is great and 64 QAM should work, but ping is still not working, it's probably layer 3 hung. So then the question is, how do I get it out of that state? I can't really talk to the modem remotely via layer 3.
SNMP is normally how we would talk to that modem.
So you tell the customer to power cycle their modem, right?
Yeah.
So it's ironic to me that when I had Docsis 2.0 modems doing dynamic channel change for dynamic load balancing on the downstream, we would change one primary to another primary, and we could have the modem reboot, or we have different techniques so the modem would stay online. And we found when some modems did a DCC to another primary downstream, and then load balance is like, oh no, I need you to move again, and it got another DCC, they would get hung. And I remember 10 years ago, Cisco, remember SA had the modems and Cisco bought SA. Internally, they had something called a Watchdog Timeout or a Watchdog Timer. And it was like an internal ping to itself. And if it failed, it would reboot itself.
Right.
So it's surprising that we don't have something like that in the 3.1 modems at the catch-all. You know, if all else fails, if the chipset or something is hung, you might need to reboot yourself, because I'd rather do that than have the customer just losing all their traffic and not know what to do.
Yeah, I tell you, if there's any modem vendors that are out there watching this now or watch this later on, drop us a note in the chat below, because I'd love to know, first of all, you know, are we correct in our assumption that when you know, there's a process here that happens when cable modems are running OFDMA in the upstream, they send their RxMER data, which is, you know, an MER measurement for every subcarrier, RxMER, back to the CMTS.
And think about it, they're not sending their RxMER. The CMTS
is requesting it.
It's getting it. It knows what it is,
yes.
Right? It's sending its downstream MER from the modem to the CMTS. But the CMTS, it's just measuring the MER because it's the one receiving the signal.
So our premise is that when the noise is introduced, that MER goes down, the RxMER goes down, and now the profile for that modem is getting changed, and possibly the modem's locking up when it's changing profiles, when it's dropping from maybe 1024 QAM to 512 QAM or some lower modulation. That's
there's so many variables, right?
Well, it could be other things as well, yeah.
Yeah, it could be trying to do profile management, and at the same time, it's trying to do a station maintenance, and at the same time, some modems were coming online. There's a lot of variables happening, right? And it's hard to test for every one of these variables. So you could have an interop, you could do Cable Labs certifications and qualification, and everything looks fine. But in the real world, you know, there's so many variables we don't know. That's why you have to usually plan for worst case. You hope for the best, but plan for the worst. Yep. And the other thing is you to stay away from where you might have problem areas, which just comes back around the circle, right? This is what we're getting at is, should I even try to do OFDMA in the low end, knowing that I'm not going to really exploit the speed that OFDMA brings to the table?
And I think that was kind of the takeaway. Was it Light Reading that Jason Miller was on yesterday? I think that was the seminar. I got that was kind of the takeaway is use OFDMA in the upstream, but don't use it any place where there's noise currently, which kind of
Yeah.
says use OFDMA above 42 megahertz. Or
If you're an 85 system, then definitely. I would not even mess around with single carrier QAM above 42 because it's Docsis 2.0 modems, Docsis 3.0 modems that may or may not work above 42. If you're going to do OFDMA and you have an 85 megahertz system, fine. But what happens in a 42 megahertz system? Even with that, we would rather see you shift your ATDMA, 15 to 20, just a couple carriers, and then do 20 to 42 with the OFDMA. What's interesting about that is and I keep saying rob Peter to pay Paul, I'm going to steal single carrier QAMs from my 2.0 and 3.0 modems, and I'm going to use that spectrum more efficiently with Docsis 3.1. The question will come up is, how many 3.1 modems need to be present to take advantage of that without me really screwing over the 3.0 and 2.0 modems? And then the question is, are there set-top boxes with 2.0 modems embedded? Are there any devices doing voice? Because the voice needs a single carrier QAM to do a proper voice and UGS flows. So yeah, there are some things to be concerned about. But even Jason brought up yesterday, Blue Ridge Cable, they had about 1/3, 33% penetration of 3.1 modems. They were able to do exactly what I just said. They dropped 4 single carrier QAM down to 2 and used the rest of the spectrum for OFDMA. So anyone that had a 3.1 modem, only a third penetration, they were just pushed to the 3.1 spectrum, which is more efficient, which helped pull some of the overload off the single carrier QAM, because now those 3.1 modems are using the 3.1 spectrum more efficiently.
And do you know if that's because they're already deploying 3.1 modems to the users who are their high capacity users?
And think about it, they're deploying 3.1 modems for downstream speed considerations. So the 3.1 modem's already there. The hardware's there. Now it's just a matter of utilizing for upstream.
Yeah, and I would imagine it. Those users are getting the 3.1 modems were probably already their high tier users to begin with. They're using a lot of downstream traffic, and by nature, they're probably using a lot of upstream traffic as well. So to your point, you don't have to get 100% of your users migrated to Docsis 3.1 in order to make a difference by using both OFDM in the downstream, and in particular to this topic, OFDMA in the upstream.
So the other thing I like is, if I drop from 4-channel single carrier QAM bonding to 2, you gain 3 dB in max transmit power. So if you have power level issues on the upstream, a lot of exclamation points on the showcase modem command, by going to 2-channel upstream bonding, you just gain 3 dB back on max transmit. Modem transmit levels don't change if they were legitimate to begin with, but the max transmit goes up by 3 dB.
And that's an unintended benefit that people may not realize they're going to get by just adding OFDM in, dropping some ATDMA or SC QAM carriers. They get that increased power level. So now your ATDMA are going to perform better. It's going to have better MER, SNR on the ATDMA channels in that power boost.
And if I drop from 4 single carrier QAM to 2 single carrier and 1 OFDMA, that's the equivalent of 3 channels. Now the OFDMA might be bigger in spectrum, but it's 3 channels. Less upstream channels means less downstream overhead for maps.
Right.
So now you have less downstream overhead because you have less total upstream channels.
So overall, you're getting efficiency in the upstream and you're getting efficiency in the downstream because you're reducing ATDMA channels and adding OFDMA channels.
And kind of roundabout way, you're saving money because you pay for an upstream single carrier QAM regardless of modulation or width.
It's licensing. You're saving money by
an upstream channel.
Yeah, you're saving money on licensing is what you're saying.
Yes. Now you might say, I'm saving on the single carrier QAM, but I'm converting that to OFDMA.
Right.
And that's fair enough, right? But maybe you pull back some single carrier QAM and maybe you use them somewhere else, or you turn on more service groups.
Yeah, I actually never looked at it from the perspective of having customers get OFDMA channels can save them money on licensing on the single carrier QAM channels. That's actually a really good point for people to consider when they're looking at what their total license counts are that they're buying.
It'd be interesting also to do cost per megabit per second.
Yep.
Because when you go 3.1 and you can run in the better spectrum
I was going to
with
say
QAM, it's cheaper.
that cost only works out if you run your OFDMA at higher frequencies. If you're running your
Exactly.
OFDMA at low frequencies, I think you're going to lose out because you're not going to be running a 1024 QAM. And I think you're also going to lose out because you're going to be running you're going to have lots of CSR calls and lots of truck rolls, at least today with today's modem firmware, because your modems are going to be locking up as soon as the noise is introduced, which we're seeing in a lot of different areas. And I'd
There's
love to
also,
have people chime in to see if they're also experiencing the same thing. I know at least across several major MSOs, this is what they're running into.
and I consider this a positive, even though it wasn't part of the spec, is I've seen some taps roll off at 10 megahertz. To me, it's actually a good thing because it gets rid of all the noise in the house.
Yeah, it's noise
Remember,
suppression.
all the noise is coming from the house. So rolling off at 10 is like having a filter.
Yes.
And that helps eliminate that noise hitting my upstream laser. But if you're trying to do OFDMA from a house from 5 to 15,
it's not a benefit anymore.
The tap rolls off at 10, that's not a good thing, right? You're causing more problems. So here's another thing most people don't think about is, and I'm going to explain this from Cisco's perspective, because I don't know that it's really necessary to do it this way, but it was probably the simplest way to get OFDMA to work, knowing where the first sub carrier works. Sub carrier 0 up to 4,000 or whatever the number of sub carriers you have. We schedule the upstream from left to right in spectrum. So if you're using 5 to 15 megahertz for OFDMA, and the modem says, I need upstream traffic, so give me some mini slots, the CMTS is scheduling at the very low end first. So even if you do an OFDMA from 5 to 10, and then you have to do an exclusion for maybe some set-top box signal, and then you do OFDMA from 15 to 20, well, that little sliver you do at the very end, that's being scheduled first anyway. That could be dictating which IUC, which is mod profile, is being used for your entire OFDMA channel.
Yep. All right, so we have some questions here or some feedback. Zoltan, so he says, so far so good already. On at least with the Era C6000, they're going to get some more experience coming up. Kai said, would love to hear more about average spectrum efficiency gains other MSOs are seeing in the real world. And Zoltan, so they already have tens of thousands of Docsis 3.1 modems. Zoltan, that's awesome to hear that you're making that type of penetration. And Kai's also saying less than 42 megahertz OFDM with noise. CMs are locking up hard. Yes, that's exactly what you heard. At least, not necessarily less than 42 megahertz, but in the lower spectrum. So I said less than 20 megahertz.
Yeah.
Kai, I'm not sure if are you seeing less than 42 megahertz in your plant, or just
I think he's asking you.
Yeah, are you asking us? Because we're seeing definitely in the less than 20 megahertz range, we're seeing modems lock up when noise is introduced. And hey, Tim, good to see you on here. You guys lean forward, pushing 3.1 modems to the field, even while you had 3.0 plant. So you just seeded for the R5 node plus 0 upgrade. That's awesome that you're going node plus 0. So thanks for the feedback so far, guys. John, so I think we've covered a good bit on spectrum allocation so far, at least on recommendations.
Bottom line, use the best frequencies you can.
Yeah, at least till we get some robust modem firmware out there that doesn't lock up anymore.
Yeah, and even if it doesn't lock up, it's still not efficient. You're still not getting the biggest bang for your buck. The biggest bang for the buck is to use the spectrum that's going to give you the highest modulation. The modems on the market today, they support up to 4K QAM in the upstream.
Right.
Same for the downstream.
Even though the spec says 1K QAM or 1024 QAM in the upstream, modems support. What about the CMTS side?
So the spec says must up to 4K QAM, may 8 and 16K QAM. So there's still two modulation schemes even higher for downstream that no one's using because the modems don't support it today. I foresee those higher modulation schemes being possible with Remote PHY, or maybe Remote PHY plus 0, no amplifiers. On the upstream, our CMTS officially supports 1K QAM, and we're now pushing 2K QAM to be officially supported, even though the modems have the hardware to support 4K QAM. In reality, the MERs that are needed to support 4K upstream, you're probably going to do with DAA. You're going to do with Remote PHY or Remote MAC PHY, something that has digital fiber to get rid of upstream laser clipping, get rid of that limitation of the analog optical link, being my Achilles heel, and trying to get better performance.
Yeah, because we need about, what, 39 dB MER in the upstream in order to support 4K QAM?
The spec has a table, and that table is on the downstream and upstream. 4K QAM is 4K QAM. I don't care if it's upstream or downstream. The cutoff was 41, I believe. I have to pull up the table again, but we know that table is about 6 dB more robust than it needs to be.
Right.
Because of LDPC and all that other stuff, it'll break around 35. When we look at the DAA and Remote PHY, distributed access architecture with Remote PHY, the MER, because the chipset's right in the node, the MER I can achieve with even 3 or 4 amplifiers and proper levels should be close to 40, close to it.
Yep.
And with 40, I'm probably going to be able to get 2K QAM unless I do like an MER offset to get rid of some of that 6 dB of conservative threshold, right? We do that on the downstream, but Jason Miller and I, we talk about we don't want to push our luck on the upstream just yet. So he and I are kind of saying just leave the MER at the cutoff, 41 for 4K QAM. I think it's 38 for 2K QAM. It's like 3 dB jumps, right? Something like that.
Yep. So, Kai did get back to us on our questions, and he said they currently only have 42 megahertz in the upstream right now, 64 SC QAM. So, good job on running 64 QAM, and fifth in the U.S. with 3.2 megahertz 64 QAM, 1.6 megahertz TDMA. And it's like you mentioned Jason Roop's name, and there he is with his awesome sense of humor. QAMs. So we'll go on from there. Good to see you, Jason. And Zoltan, they're running 4 by 6.4 megahertz at 64 QAM in the upstream, and 10 megahertz OFDMA at the moment. Love to know what frequency you're running that OFDMA channel, Zoltan. So good to hear that's running.
Yeah, to be honest, I'm seeing that, and Cost Communications, a few other people, maybe they didn't have the 3.1 modem penetration, or they're apprehensive or nervous about doing 3.1 upstream until things are stabilized or they test it out. But a lot of people are activating a 5th upstream of single carrier QAM, and I personally don't like the idea, because remember we talked about max transmit? As soon as you go past 4-channel upstream bonding and you just go to 5, you might as well go to 8 because it drops by 3 dB.
Yep.
As soon as you add that 5th one in, it's always a doubling effect, regardless. Like 3-channel upstream bonding is the same as 4 in regards to max transmit.
Mm-hmm.
5 is the same as 8 because you got past 4. So you lose another 3 dB in your max transmit, and you're paying for that channel. So yeah, I understand a 5th upstream maybe just for set-top boxes makes sense to me, but throwing a 5th upstream in there to get a little bit more speed, you just get more bang for the buck if you go OFDMA, if you can justify it with the number of devices, obviously.
Yeah. So Kai made a comment about having a 10 megahertz OFDMA upstream, and I think that's something important for people to know. Is like the Docsis spec says we can have a 96 megahertz upstream, or we can have a 6.4 megahertz upstream. We can have variations in there. So if operators don't realize that you can have like different channel widths for OFDMA in the upstream, that's something you want to recognize. It doesn't have to be fixed to 96, doesn't have to be fixed to 6.4. You can use different variations in there. Kai's also mentioned, I think this was in there, so he's kind of saying this is something that's worrying him, that modems are locking out, and also he's mentioning, maybe one firmware vendor, you're not going to have any problems with lockup, but a different firmware vendor, you are going to have or even a different firmware in the same modem, you're going to have problems with locking up. That can be a real issue. So it is legit something you want to test in the lab, inject some noise before you deploy these out in the field, depending on where you're going.
And it's always good to have the different Intel versus Broadcom. It's the two manufacturers of the chipsets, right?
Right.
So if you have one that's Intel based and one that's Broadcom based, it's good to see if there's any nuances between the two. So if you see modems locking up in the field, are they all one chipset vendor?
Yeah.
And if they are one chipset vendor, then maybe you can identify, are they all the same firmware? You know, and there's a lot of times there's firmware upgrades that are available and people just don't know about it.
Yeah, so that's really good point, John. You want to test all modems and all firmware versions, and before you roll out that next firmware version, it's really good to have a lab setup where you can test that and test it under the conditions. Like, try to emulate the outside plant in your lab environment as much as you can. So, John, Kai has a question pointed directly at you. He's saying, John, we only I lost my place here. We are only permitting 4 of those 5 active upstreams at any time because of the new transmit issue, max transmit issue.
So one way to do that is you just make, because you make upstream bonding groups manually, you just make a 4-channel and 4-channel kind of overlapping, right? You could have 2 4-channel bonding groups. So you activated the 5th upstream, but you didn't make a 5-channel bonding group, which is fine. You know, and a lot of 3.0 modems might be relegated to only 4-channel upstream bonding. It's only the full bandwidth capture modems that were like 24x8 or 32x8. They supported more than 4-channel upstream bonding. So a lot of the modems in the field might only be 4-channel capable anyway.
Yeah.
Right?
Absolutely. And Tim's now asking, so a 3-channel SC-QAM bonding group plus the OFDM would be preferred for power levels.
Yeah, but it's interesting about 3.1 is it's considered 4 channels, but the max transmit is based on actual bandwidth, not just channels anymore. Because with 3.0, you could never do anything bigger than a 6.4 megahertz wide channel, and you could never do anything higher than 64 QAM. So the max transmit wasn't based on channel width, it was based on number of channels and modulation you were going to run. So the max transmit was always based on that. With 3.1, it looks at all the spectrum. So all the single carrier QAM and all the OFDMA active subcarriers, and does the math on that to say, all right, 65 dBmB is the max transmit I can do. But because of all these carriers, what would be the max transmit per 6.4 megahertz wide channel?
Right.
And 3.1 modems actually report their transmit level based on 1.6 equivalent bandwidth. So there's a little bit of mathematics that has to happen, or you have to have some commands that equate the 1.6 back to 6.4. It's really just a 6 dB difference.
And the other thing I would add on to Tim's question is I would put the OFDM higher in frequency than the SC-QAMs for all the reasons we've mentioned so far. Zoltan brings up another topic that we've discussed before, which is mixing RFOG in with our OFDMA in the upstream, because we've discussed this many times, John. You'll probably want to add on that RFOG has real compatibility issues with OFDMA in the upstream.
So 3.1 modems schedule upstream traffic in mini slots, and the mini slots are a bunch of subcarriers and typically 400 kilohertz worth of subcarriers. So if I'm doing 25 kilohertz subcarrier spacing, that's going to be like 16 subcarriers to make 400 kilohertz worth of spectrum. So if that modem, if it was a 3.0 modem, it would burst up the entire channel, right? But if the 3.1 modem is bursting up mini slots, there's 2 problems here. One, as a CMTS, I could be scheduling one modem for so many mini slots and a different modem for other mini slots in that channel. So now I have 2 modems coming on at the same time, causing the same upstream laser wavelength, causing OBI, optical beat interference.
Yep.
So this is the problem with RFOG, is how do I get one house to burst at a time? OFDMA doesn't work like that. You'd have to create a new scheduler on the CMTS to only allow one modem at a time to burst OFDMA, even if he doesn't even need it. So if he says, I only need to transmit some voice traffic or some minuscule amount of traffic on the upstream, and it's a 3.1 modem, and the OFDMA is 20 megahertz wide, but he only needs 800 kilohertz to do his traffic. Well, now you're basically saying that modem's going to use all the time because I can't allow his laser to come on the same time as somebody else's laser.
Right.
So it's kind of a mess. OFDMA and RFOG, it's not going to be too clean. And to make matters worse, the upstream ONTs, the optical network ONTs,
ONTs, optical network terminators.
Terminal.
Oh my
terminal.
God, terminals. Yes, terminals.
So it has a switching function in it for RFOG.
Mm-hmm.
It senses signal coming in, whether that's real signal or noise, it doesn't care. It has a certain threshold that says when that power comes in, open up so my laser can transmit. This is how RFOG and DPON works. One laser at a time, might be 32 lasers all coming back to one optical receiver.
There can be only one, John.
There can only be, that's true.
Highlander was such a good movie.
The Clan McCloud. That's what the cloud is, the Clan McCloud. Right. There can only be one. So if the upstream laser needs a certain amount of level to activate the switch, how much level is coming from a 3.1 modem if it's only transmitting 400 kilohertz?
It's not very
if
much.
You do it's very low because
it's very low.
If you did
so you can't have enough energy to turn the laser on.
That's what's happening.
Yep.
That's happening now with a lot of people. Is that burst of OFDMA is not even enough power. And I did some math in that, and I saw it's probably like a 10 dB difference because it's 400 kilohertz. And if you're trying to do 40 megahertz, that's a 1-to-10 ratio. 10 times the log of 10 is 10 dB.
So does the modem know that? Does the modem then retransmit and just keep retransmitting? It's like if a tree falls in the woods and no one's there, does it make a sound?
So it's almost like now we need ONTs to lower their threshold or somehow change padding in the house to make the level look higher. But does that make the modem like max transmit as well?
Yeah, but then the ONT can start transmitting when there's noise in the house, which is why the level's high to begin with.
Yes, there's like a not a hysteresis, but like a squelching function. So that's the whole reason we don't want the ONT to open up for regular noise.
Right.
We want it to open up for a real signal, but that real signal now is less
too low. It looks just like noise.
Yes.
So
actually, the math would be because the power level that's negotiated for 3.1 is based on a 6.4 megahertz channel. The math will be 10 times the log of 6.4 divided by 0.4. 400 kilohertz.
Mm-hmm.
And that's about 12. 10 times the log of 12 or whatever is like
it's just doing your head. You are a human calculator. So thanks, Zoltan. This OFDMA and RFOG issue is a huge problem. We've got a bunch more questions to get here, but I'd love it if people would subscribe and give us a thumbs up if you've not done so already, and hit that notification bell to get notified if you like what we're talking about. This is a great topic today. We've got lots of questions. Some more questions coming up here. Jason, OFDMA becomes OOFDA. Thanks, Jason. Tim, I liked your comment, what you said there, because that is something interesting that doesn't always get mentioned. There are some differences between the Intel chips and the Broadcom chipsets, and you're observing that in your lab where the Broadcom chipsets are dropping the OFDMA on a command and rebooting, but you're not seeing that same thing with the Intel chipset. So recommend to everyone, do your testing. Jason, collusion. Kai at Tim. So you're just responding back to Tim on that. Thank you, Optical Network Terminal. Stevens for I'm using your last name. I don't want to mess up your first name for clarifying that on that. So Tim, you're just confirming modem goes into partial mode on the upstream bonding. So yes, on the restart restores the full bonding with the power cycling of the device.
So let's go down that route. Let's cover that one.
Okay.
Partial mode was one of the things you and I talked about.
Yep.
To me, the more upstream channels you have, I just said too many is a max transmit power issue maybe, but having more upstream channels that all have station maintenance is like built-in redundancy, because it's not like downstream where you have one primary downstream, right?
And you
If you
lose
lose
it and
that
you're
primary,
gone.
modem goes offline.
Yeah.
But on the upstream, for lack of a better term, they're all primary. On the upstream, every upstream channel you're locked on is doing station maintenance. So if you lose one, it's not catastrophic because you have
It's a
other
safety
ones that
net.
rely on. Now, the OFDMA is interesting because within the OFDMA, you have profile management. You can go from 1K to 512, 256, all the way down to the lowest IUC of IUC 13, which might be 16 QAM. But once that breaks, you're hoping the CMTS knows when to say, all right, quit scheduling any traffic on this poor performing upstream channel,
Impaired
and go to
channel.
partial mode, and now schedule all your traffic on the single carrier QAM.
Yep.
Hopefully that one modem doesn't overload everybody else, eat up his fair share. But at least he's online, he's in partial mode, he's still getting traffic, and he can automatically come out of partial mode if the problem goes away.
If and the
that's what we're
CMTS
hoping.
knows to say start using that channel again. Because
Yes,
that's also been an issue where once you get into partial mode, you never come out of partial mode.
correct. Especially on downstream when we rely on the modem to send something called CM status messages. And what if those messages come on the upstream and they never get to the CMTS?
Right.
Well, then the CMTS is like, I never heard you, so now what? And the modem just stays in partial mode forever, maybe. So there's a lot of recommendations for downstream partial mode. Upstream partial mode, we're just going to keep trying to do station maintenance to that upstream, even though there's no traffic scheduled. And if the station maintenance goes through and we get some good MER readings, then we're like, okay, now we can reactivate that upstream channel for that modem.
Right. So that's really, I mean, so partial mode, we've lost that channel. What do you see as far as the probability that that channel is going to come up once the impairment's gone?
I mean, it should be 90%. It should be 95%. But coulda, shoulda, woulda.
Yeah.
You see some odd things sometimes where the modem might not come out. I'll give you an example. Good buddy of mine, they were doing, and this is Docsis 3.0, they were doing analog fiber redundancy path testing, not digital fiber, analog, different path lengths. Let's suppose a modem's in partial mode, and the CMTS is always trying to do station maintenance to the channel that's not up. And the modem now goes to a different fiber path, and now the time offsets are different. So now when I'm trying to do station maintenance to the upstream channel that modem is not using, but the time offset is bad, and the time offset never gets updated because it doesn't have station maintenance. This is like a round just snowball out of control. It never comes out of partial mode.
Yeah.
And because the time offset never updates on that one, it just never comes out of partial mode.
And that's what I see, and we've got Tim Bowser confirming that's the issue that he's seeing as well. It's not coming out unless they reset the modem, which is a problem. And hey, Owen, the real Owen Parsons, good to see you on there. He's also saying if you have fiber going to house, don't do RFOG.
if it hurts when you do that, don't do that.
Yeah.
It hurts here and here. Oh, it's your finger.
I got my finger in my eye. Why's my eye hurt?
It hurts here. Oh, it's your finger.
Yes. So, Jason Roop saying, it's talking about the Cyclic Prefix.
So, and Jason talked about this. Jason Miller talked about this yesterday. And some people say cyclic or cyclic prefix, whatever it is.
You say tomatoes. I say tomatoes.
Yeah, I know, right? And it creates overhead, but it's to give you more robustness. And on the downstream, we found that if you do a lower cyclic prefix, you can get a significant amount more speed. Significant is a relative term, but you get more speed, especially with 25 kilohertz subcarriers. So we have all these recommendations for more speed. The trade-off is it could be less robust. But if I have downstream spectrum that's not in roll-off, not have LTE interference, not having problems in the spectrum, then maybe I don't need it. So cyclic prefix can make a difference on downstream, but he mentioned this yesterday, Jason did, that cyclic prefix on the upstream doesn't seem to have as much effect. So getting a lower number can get a little bit more speed, but it's a smaller channel, so it's really not a lot more speed. So we don't see as much change with cyclic prefix on the upstream as we do on the downstream.
Right. And for those who don't know, cyclic prefix is a setting in the CMTS, correct, John? I mean, it's not something you're going to do in a fiber node or in the outside plant.
It's the configuration of your OFDMA channel. So you're configuring some parameters, symbols per frame, cyclic prefix. On the upstream, you can't configure the guard time. The guard time is hard set at 0.5 megahertz on both sides, the guard band, if you will. So it's 0.5 megahertz on both sides. So if you do 25 kilohertz subcarrier spacing, the smallest channel you can do is 6.4. But if you include the 0.5 megahertz on both sides, it's really 7.4.
Yeah. So, so something we've talked about before, we haven't got to, is max power and DRW. We did talk a little bit about power, but the dynamic range window, DRW. So I wanted to hit that a little bit where we're talking about OFDMA.
This one perplexed me a little bit because it's spelled out in Docsis 3.0. And Docsis 3.0, it ends at 85 megahertz on the upstream. So it's a 12 dB window, which means we all know when a modem transmits at different frequencies, it's going to have to transmit different level to hit the CMTS at 0 across the board. So to hit the CMTS flat, I'm going to have to transmit maybe higher transmit at the higher frequency to overcome the attenuation in coax. Because we don't have automatic level control. Yes, we do balance our amplifiers, but we still have coax from the house to the first amplifier. So you have temperature effects, you have coax effects, you have frequency effects. So the higher I go in spectrum, the more I'm going to have tilt coming out of my modem so that I can go through the coax and then hit the CMTS flat at 0.
Mm-hmm.
So what is the difference between those transmit levels? Well, that's the DRW. Can't be more than 12 dB. So if I'm transmitting at 40 dBmV at 10 megahertz, I can still transmit at 51 dBmV at 85 megahertz. That would be 11 dB delta, and it still fits in my DRW. Docsis 3.1 kept that same spec of 12 dB, but we know the upstream was expanded to 204. So I'm like, man, that if all things being equal, shouldn't the 12 dB be extrapolated out to 204 and been like 20 dB?
Yeah,
like my DRW should have been 20 dB.
Because going up to 204 megahertz, we know that we have attenuation.
You're more than doubling it.
Yeah,
you're more than doubling the spectrum.
And so we also have cable loss is not flat. We have attenuation that gets much more significant as we go up to 204 megahertz. That's going to be problematic, and that's why you're worried about that 12 dB window. The other thing that I want to know about that 12 dB window is what happens if you have a suck out, or what happens if you just don't have a linear tilt in the cable, standing waves, suck outs, something like that. That also impacts that 12 dB window.
Yes, I mean the CMTS is just looking at the delta. It doesn't care what your RF problems are.
Yes.
It's just looking at the modem transmit levels. And remember, when you do MTC mode, which is upstream bonding, it's called multiple transmit channel set. When you do upstream bonding, the modem is required to report its transmit level to the CMTS. So if you do show cable modem verbose or show cable modem MAC address PHY, the modem transmit level will be reported even if you're not doing remote query. Remote query is an SNMP function where the CMTS is talking to the modem to get its transmit level. So we can do that with Docsis 2.0 modems, but remote query has to be configured. With 3.0 modems doing upstream bonding, you don't need remote query because it's required by spec for the modem to report its transmit level to the CMTS.
Mm-hmm.
So I can see the modem's transmit levels. That CMTS looks at the transmit levels of all the channels for that modem, says you have to be within 12 dB and you have to be within max power, or I'm not going to let you do that bonding group you're trying to do. So if you're trying to do 5-channel bonding and the power doesn't work, I'll relegate you to the next lower bonding group. Oh, you have a 4-channel bonding group. Oh, that gives me 3 dB more power. So maybe I'll put you in a 4-channel bonding group. So CMTS makes those decisions. And that DRW, it doesn't care if the plant is like this or a roll off. That's a big one, right? If your 40 megahertz, 42 megahertz rolls off hard, and you put a carrier at 42 megahertz, it has to overcome that roll off of all those diplex filters through all those amplifiers. So now that channel has to transmit maybe 7 dB higher than all the other upstream channels.
So
would that overcome the roll off?
Would that kick on? So let's say that we had 3 ATMA channels and an OFDMA channel, and that OFDMA channel just happens to be in a roll off. That roll off exceeds the DRW. Would that cause the modem to drop the OFDMA channel and just spawn to the ATDMA
now
channels?
Here is the interesting thing about the OFDMA is, how is it equated to a channel? It's not 6.4. It might be 24. I mean,
it's whatever width it is. It's like Kai said, they have a 10 megahertz OFDMA channel. So could be whatever it is.
We don't look at the level of all the subcarriers. Like, if I look at the 10 megahertz OFDMA, it's one channel, but what frequency are we actually looking at for the DRW?
I don't know. You tell me.
My understanding is, what frequency do we use for initial ranging?
Yes.
And that is set by you. You can decide where to put the initial ranging in that OFDMA block. By default, it's 1/3 up from your lower band edge.
Oh, that is quite interesting.
If you put the IR, initial ranging, at the very high end, that would be worst case for ranging.
At the very roll off. So in the roll off window.
But if you put the IR, initial ranging, at the very low end, lower frequency, you might be better off because you'd have less dynamic range window problems.
Right. Because you're kind of taking it. So if you imagine that you're in a tilted plant, maybe with some roll off on the end, what you're saying is put it at the lower end, because now you're kind of balancing where you have roll off at the high end, roll off at the low end.
So then the question is,
why would you not center it though? Wouldn't maybe centering it be? I can understand maybe why they're picking 1/3, but maybe centering it might even be a better place.
I think it really comes down to understanding your spectrum. You might just say, if I put it in center, it's going to be at 27 megahertz and I have a probability of CB coming in. So maybe that's not a good idea.
Yeah.
Maybe I put it at 30, 35. Maybe because I'm doing an 85 plan, I put it at 65. So I think you'd have to look at your own spectrum and say, where should I put initial ranging? Now, it's BPSK, so it's really, really robust. But it's going to dictate that DRW. It's going to dictate the power level. And then your question might be, well, all right, let's say the IR is near the lower frequency, but I still have roll-off. OFDMA still has pre-equalization. It'll take care of some of that roll-off and that tilt within the OFDMA block.
Yeah.
So you do have pre-equalization to take care of that.
So Kai is saying that they have tons of Docsis 3.1 modems that their event logs are complaining about transmit power. They couldn't adjust transmit power because the change would be more than 6 dB below the max of the DRW. Can someone explain this?
Below the max. So the DRW is +6, -6, 12 dB window. The question would be is, where's the middle part of this +6, -6? Here's the weird thing about 3.1 modems as well. If the modem is in a max transmit scenario, meaning one of the channels is max transmit already and the other channels are below, you can't go +6 above the max and -6 below. Like, where is that middle ground? That +6, -6, I believe if you're at max, it might be, I can't remember now. It might be right at the max. So your 12 dB window is not 12 dB anymore because you're already at max. You don't understand what I'm saying?
Yeah.
If you were at a legal transmit level, you'd have a +6, -6, 12 dB window to fluctuate in there because this one is not at max. The +6 is not at the maximum transmit power. But if a modem is in a situation where one of the upstream channels is at max transmit, it's kind of like you're moving it up, you're hitting the max and it's squishing down your DRW. And now technically it might only be an 8 dB DRW.
So basically we're stumped, John, is what you're saying.
Yeah. Yes.
Stump the chumps again. Kai, you get the prize today, man. You stumped us. And Kai, I apologize on the 10 megahertz for OFDMA. Zoltan, thanks for clarifying. There's a lot going on in the chat window today. I did want to follow up, Jason. I saw you made the point back there about the cyclic prefix and tuning the cyclic prefix. And that's something that, John, you set the cyclic prefix once and you never forget about it? Or is that something that actually needs to be tuned?
You could, is my favorite saying, you could make the argument that
it depends.
CMA, machine learning, artificial intelligence would be a great feature to optimize upstream parameters on the fly and make mod profiles. But there's always a trade-off of complexity versus keep it simple, stupid, the KISS principle. And having external devices do some of these calculations and then have modems dynamically change. We can make things as complex as we want to, but then we're opening ourselves up to some problems later on that maybe we don't understand. And for now, we have IEC 13, 12, 11, 10, 9, and then I think it's 5 and 4. We have 5 mod profiles we could set. And then in those mod profiles, we could also do override zones. So we could say IEC 13 is 16 QAM, so real robust. That's the one modems use to come online. And then when the MER readings come through, we can assign those modems to 1K QAM, 512, 256, maybe something with mixed profile or some override zones. So we have a lot of options that the CMTS can decide where to put the modem. This is without artificial intelligence. It's just looking at thresholds, looking at MER, looking at uncorrectable FEC. Where was I going with this?
Well, we were talking about how frequently to change the cyclic prefix.
Yeah.
I mean, yeah.
It'd be the one thing you set and you hard set it and you're done.
Yeah.
But with that said, I think later on when we start really wanting to push 4K QAM, 8K QAM, 16K QAM, now we have some one-off modems that might be capable of doing it if we had more smarts.
Yes.
Artificial intelligence.
And that's smarts. When you talk about PMA or profile management application, that is something that we on the Nimble this side of things we have integrated into our application, that we do think there is some real advantages to that, particularly to your point, when you have noise, when you don't have noise, and you want to go to higher modulations. We think there's going to be a lot of advantages to that. So
I think if you do remote PHY with less amplifiers and Docsis 4.0 modems come out that support higher modulation schemes, I suspect I could get quite a few that would run the higher modulation schemes that we think are not possible today.
Yes.
Well, one, they're not possible because the modems don't support them. They only go as high as 4K QAM. But we have systems running 80% of the modems at 4K QAM without PMA. So there are some scenarios where the MER is good enough and we're not putting in too much overhead because we know the modem can drop down to 2K or 1K on the fly. So that's for downstream, right? But I really do feel on the upstream, we could probably squeeze out even more bandwidth if we get a little smarter. And like you said, we could on the fly maybe change cyclic prefix or the IUCs or override zones and all kinds of other stuff. With more complexity. Hey, I wanted to offer one more thing is, because here's the good thing about 3.1 modems. If you're only doing 42 megahertz, your max power issue shouldn't be a problem, because if a 3.0 modem worked okay, a 3.1 modem is going to work better because there's more power in a 3.1 modem than a 3.0 modem.
Right. With
all things being equal, because the 3.1 modem is spec'd out to 204. So its power level really is for 204, and you squoze it, you squeeze it down to 42. So it already has 5 to 8 dB more power than a 3.0 modem.
Yep.
So that right there gives me a little bit more power to work with. With that said, you could set the CMTS to have an OFDMA like +5 and the single carrier QAM 0. You could force the modems to transmit 5 dB, 3 to 5 dB higher to get better MER, to get better modulation.
And that's just a benefit out of 3.1 modems. I think we said that before. The 3.1 modem's always going to perform better than a 3.0 modem. So, I think like Tim Bowser said, they made a hardcore press to get 3.1 modems out there. So that's an awesome
until
thing.
It locks up. Until it locks up.
Yes, there is that when they're running OFDMA. So John, we are out of time. Chat room, this was a phenomenal show with all the contributions. I apologize if we did not get your questions answered today, but it looks like we have some more work to do, John, on the DRW window, because there are some folks saying that there's a lot of cryptic messages in there. I don't think we fully answered those questions. We're going to do that on a follow-up episode. I think we have a lot more to cover in OFDMA as more operators roll this out. John, we had mentioned before that the SCTE call for papers is now available. So, folks, if you got good information, make sure you check out SCTE and get your contributions for papers in. Our next episode is on March 19th, a roadmap for Docsis 4.0. John and I will be here, and Jeff Finkelstein will be joining us for that episode as well. So please do drop in, join us in the chat room, and get more questions in. We love answering them. So, John, I want to thank you for your time today. Everyone in the chat room, thanks for the great contributions. We'll try to follow up on some of the unanswered questions the best we can, and we'll look forward to seeing you on our next episode. So, John, thank you so much.
All right. Have a good weekend.
Have a good weekend, all. Everyone, thanks for chatting. So long.